All right, this is going to be a video that goes along with 9.2b, compound interest. So we're going to look at a couple different compound interest formulas and how they work. So first, what is interest? So there's two types of interest. Either it's interest that you earn or interest that you pay. So when you store money in like a savings account or a retirement account, the bank pays you money for keeping that money in the savings account. You're earning a certain percentage. That's called interest. That's a positive interest. So like you're earning money here, positive amount. There's also a negative money or negative amount of money that you pay when you owe someone money. Like if you owe the bank money for a loan or a credit card, you're borrowing money from them, then you pay interest on it until you pay it back. So that's the second type of interest. When interest is compounding, it can be collected or earned on a regular schedule. So it's basically the collection or earning the money on a regular schedule during the year. You can have sometimes interest only accrues once a year, so annually, one time. It could be monthly, so it compounds 12 times throughout the year, or you earn it 12 times throughout the year. Could be weekly. There's 52 weeks in a year, so you could be earning it every Friday, or you could be paying interest every Friday, or it could be compounding daily. You really have to be careful with that if that's money that you're paying, because the interest could be compounding, going back into the loan, and you're paying interest on top of interest every day. So that can add up very quickly. Ends up being an exponential growth type of situation. So those are just some examples. We'll go through some more as we go here. So how do they calculate how much you owe or how much do you earn? They use this formula. It's the compound interest formula. These are I will give you the formula, so that's easy to find. You can look it up. I'll give it to you on the test, but you do need to know what the variables represent. So in our last growth model, A was the initial value. It's kind of similar. A is but A is the total amount, and P this time is our starting amount. It's similar though because it's out front. It's in the very front of our equation, like in the growth models. R is the interest rate again. It needs to be a decimal, same as growth and decay models. N represents the number of times something is compounded in 1 year. So if it was compounded monthly, N would equal 12. So if it's compounded monthly, N equals 12. And then T is in years again. It's time in years. So here's our equation. You'll need to know what the variables represent so you can plug into the right spots and then be able to calculate it correctly with the calculator. So let's try a couple. So you deposited $1,500 into an account that pays 6% annual interest. Find the balance after 1 year if it's compounded annually, quarterly, or daily. So the thing that's changing here is that how it's compounded. So if it's compounded annually, N is going to equal 1. If it's compounded quarterly, that's 4 quarters. 4 quarters in a year, quarterly, N equals 4. If it's compounded daily, N would equal 365. The rest stays the same for each equation. So you deposited $1,500 into a bank account. So $1,500, that's your initial value. So P is going to be $1,500. Our starting value. Our rate, we got 6% annual interest, so that's going to be 0.06 as a decimal. Remember, you move it 2 to the left. And then I want to know the value after 1 year, so our time is going to be T equals 1. Then we plug it into this equation. So I'll start with the annual one. So A, that's going to be our total amount after this year. Is going to be the initial amount, $1,500, parentheses, 1 plus, and then you do the rate, 0.06, divided by the number of times it's compounded, so divided by 1, over, and then it's N times T. So in this case, it'll be 1 times 1. So N is 1, T is 1. Then remember to use Pemdas when you are solving for these, so you're doing order of operations. So first do what's inside the parentheses. So 1.06 divided by 1 is just 0.06. 1 plus 600ths is 1 and 600ths. And 1 times 1 in the exponent is 1. Then take 1.06 to the first power. So then next do your exponent comes next, and then take it times 1,500, and you're going to get $1,590, which tells me that $90 was the increase, so that's how much interest you earned in that year on that percentage. So if n equals 4, it's going to be a equals 1,500. 1 plus r, so 0.06 over n, so plugging in 4 there since it's quarterly this time, to the n times t power, so it'll be for the 4 times the 1 power. So n is 4, t is 1. Following my order of operations, I'm going to get what's inside the parentheses here. You do 0.06 divided by 4. And you get 0.15, and then 1 plus that's going to be 1 plus 0.15. And then on the outside here, 4 times 1 is to the 4th power. Then I did the exponent here first, and then times it times 1,500, and I'm going to get $1,592.04. So I really would recommend that you pause and try to do some of these calculations, because the biggest mistake students seem to make is plugging into the calculator correctly. If I did the calculations for daily, I ended with 1,592.75. So the number of times when the number of times that it compounds increases, the more interest that you pay or the more interest that you receive. So we started with $15,090, we got $90 in interest, then we got $92.04 in interest, then we got $92.75 in interest. So the more times it compounds, the more interest you pay or the more interest you receive. So typically, if you're receiving it, then you want to compound more. All right. I'm only going to do one of these just for time's sake for watching the video, but again, we're using the compounded equation. So a key word here is compounded. If it's compounded annually, then remember n would equal 1. If it's compounded quarterly, that means that n would equal 4. And if it's compounded monthly, since there's 12 months in a year, n would equal 12. In this equation, you're depositing $800, so that's my initial starting value, which is my P. The account pays 4%, so R is going to be 0.04 in the equation. And I want the balance after 2 years, so I want the balance after T equals 2. So I'm just going to do for monthly, I think. So I'm going to plug this into my equation, 800 for P. 1 plus 0.04 divided by 2, and then n times t will be 12 times 2 up here. So to figure this out, I did what's inside the parentheses first, starting with the division. So I did 0.04 divided by 2. Oh, I wrote that wrong. It should have been divided by 12 because its n is 12. So 0.04 divided by 12, I got 0.0033. Then adding 1 to it, I got 1.0033. The decimal, I just took 4 decimal places. And then I did the 12 times 2 on the outside and got 24. Next, I did this to the exponent of 24. Then I took it times 800, which finally ended with 866.51. So if you want to stop here and try the other two and see what you get, this is how much money I got when it was compounded monthly. If it was compounded annually, my answer was $865.28. And if it was compounded quarterly, I got $866.29. So a lot of times students make a mistake doing the order of operations incorrectly or punching it into their calculator and the calculator does it wrong because you don't have the right parentheses. So you got to be careful. So I definitely suggest practicing putting those in so you know how to do it correctly. The next one we're going to look at is, I remember it as PERT equation, like P-E-R-T spells PERT. It's when compound interest is compounding continuously. So those are going to be key words. Anytime you see continuously, then you need to use the PERT equation, which is P to the E to the RT. So if you see compounded monthly, annually, yearly, anything like that, you're going to use the other formula. If you see the word continuously, you use PERT. So P to the E to the RT. I don't know, it's kind of how I remember it. Anyway, P still represents the starting value. R is the interest rate. T is the number of years. A is your total amount in the end. The only thing that's different is we have this E in there. Now, if you look at your calculator, you'll see a button. It's going to either look like E to the X or E to like something like that. And when you use the button in the calculator, it'll give you like E to the caret and then some number. If you did E to the first power, so just E, well, E equals, it's a decimal, it's irrational, it's kind of like pi, where it goes on forever, so they gave it its special button. It's approximately equal to 2.71. So when you're using this formula, you're going to use this button, E to the X, or E, and some calculators just say E. But, so, when we read this then, we were depositing $500. The account pays us 3% interest. We want it after the balance after 2 years. It's compounded continuously. So since it's continuously, that tells me I need to use PERT, which is P times E to the power of RT. So this is P times E to the exponent of RT. So when we plug in here, we got our P is going to be our initial amount of $500. Our rate is 3%, so that's going to be 0.03. And I want time after 2 years, so when T is 2. So the total amount will equal 500 and then E to the power of 0.03 times 2. So the way that I enter this in my calculator, and it's very important, is you're going to do this part first. So you're going to type in E to the X, and it'll look something like E to the power of, then you put in 0.03 times 2, and make sure you got your parentheses around that whole thing. Then hit enter. And I got the decimal, when I did that, I got a decimal of, let me see, where is it at here? 1.0618. I took 4 decimals because I didn't want to round too early. Then when I did 500 times that decimal, I got 530.92. So now I rounded to 2 decimal points because I was talking about money. So if my interest is being compounded continuously, so all the time, every second of every day, I will earn $30.92 in interest after 2 years if it pays 3% interest. We'll do one more with PERT. So $1,500, 4% interest after 3 years. It's compounded continuously. Since it says continuously, I know I'm going to use the PERT equation. So it's going to be A equals, our starting value is 1,500. We got E to the power of, the rate was 4%, so 0.04, times 3 years. So then I'm going to put this in the calculator first, which is, I'm going to use the E to the X button. It's going to be like E to the power of 0.04 times 3. When I did that, they gave me the decimal of 1.1275. I just used 4 decimal points. I didn't want to round too early, too soon, so 4 seems good. And then 1,500 times that decimal is 1,691.25. So about $191.25 in interest. This would be my total amount in my account after those 3 years. So that doesn't look too bad there. If you can find an account that pays you interest continuously, that would be awesome. And I think that's it. So just remember that PERT is used for the P to the E to the R to E is used when you have the word continuously. The other formula is used for everything else, the 1 plus R to the N to the NT. This one's used for if you have monthly, annually, annual interest, etc. Monthly interest, yearly interest, it's compounded quarterly, monthly, daily, weekly, anything like that, you use the second equation. PERT is for continuous interest. All right, maybe you can figure out how much interest your bank account is earning you. Have a great night.